Okay, so last class we talked about imaginary numbers. And how do we get an imaginary number? Yes, I is the imaginary number. How do I get it? Where does it come from? Negative where? Negative 1 what? Yeah, you got to have a negative underneath the square root to get an imaginary number, right? So we talked about imaginary numbers. We also talked, well, square root of negative 1 is I squared is negative 1. Okay, you have to have those two things memorized. We also talked about complex numbers in the general form of a plus bi, right? And we learned how to add those together and subtract them and multiply them and divide them. So we have to learn a little bit more about those today, and then we're going to learn about how we graph them, okay, which is actually very simple. So distance of a complex number from the origin. We also refer to this as the magnitude of the vector, okay, the length of the vector, the magnitude of the vector. This is very, very simple to find. All you have to do is take the absolute value of the complex number. So if you're asked to find the magnitude of the complex number 3 plus 4i, all you're going to do is put it in your calculator as the absolute value of 3 plus 4i. And it's going to give you a non-vector value. It's going to give you a value without the I. Okay? 3 plus, absolute value of 3 plus 4i. I'm going to throw a calculator page in real quick. Absolute value of 3 plus 4i is going to give me 5. So that's its magnitude. Okay? So if it asks for magnitude, you throw it in the absolute value. Got it? Okay. Okay, so multiplicative inverse. Let's think about this in terms of just a regular number, 3. Okay? Multiplicative inverse is what you multiply by to get the multiplicative identity. What's the multiplicative identity? 1. So what would I have to multiply by 3 by to get 1? What's 3 times 3? Okay. 3 times 1 is, think before you speak. Try again. Say it. 1/3. Yeah. What's 3 times 1/3? Okay, because those cancel, I simplify and I get 1, right? Okay, so how about if I had 4? 1/4. What am I multiplying by? What's the word? Which is also known as the reciprocal. Okay, so if I'm looking for the multiplicative inverse of 3 plus 4i, what's the multiplicative inverse going to be? Yeah. You guys are not catching on quick today, huh? Wakey, wakey. I know it's early. Reciprocal, right? We're just taking the reciprocal, multiplicative inverse. So what if I wanted the additive inverse? No. Additive inverse. So additive inverse means what can I add to it that'll give me back my additive identity? What's my additive identity? Think again. Additive identity. What can I add to anything that won't change it? 0. So what can I add 3 by? Add to 3 to get 0. Negative 3. How about if I had negative 4? Positive 4. What am I adding to it? What's the rule? Yeah, the negative. So if I had 3 plus 4i here, its additive inverse is going to be negative 3 plus 4i. You just make it negative. Okay? Which, as we know, is the same thing as negative 3 minus 4i if we distribute through that negative. Okay? So now you've got your multiplicative inverse and you have your additive inverse. Okay, so this is done. I want you to go and open 14b. And we're going to talk about graphing parallelograms. Okay, so graphing parallelograms is actually really, really simple. Okay, not difficult at all. Complex numbers, a plus bi, that's our general form, right, may be graphed as either points or vectors on a coordinate plane. Generally, we graph them as vectors. Do you guys know what a vector is? You're going to learn. Okay, on a graph, the real axis is no longer called the real axis, or x-axis, we call it the real axis. And the horizontal axis, that's your horizontal axis. Your vertical axis is now your imaginary axis. So if you have a graph, right, this is going to be labeled real. This is going to be labeled imaginary. You are no longer dealing xy. If you graph a complex number on an xy plane, it's going to be wrong. Okay, it doesn't exist on the real axis. You have to have real and imaginary. Got it? Okay. So the ordered pair for a point on the complex coordinate is your real and imaginary. So if I had 3 minus 2i, okay, and I wanted to graph this, what I would have to do is think about it as a point. Your x value is now your real part of your complex number. What's your real part here? 3. And your y value is now your imaginary part. What's your imaginary part? Negative 2i. Yeah. Okay, so we wind up graphing this point. It's really very simple. Okay? Can I make this go away? Yeah? Okay. So the ordered pair for a point on the complex coordinate plane, again, is real imaginary. The complex number a plus bi is either graphed. I think I just said all of this, didn't I? I don't know why. Oh, okay, so the vector, it starts at the origin, okay, and we draw it right to the point, and we put a little arrow. So it's kind of like a ray, drawn as a ray, okay, so that's what a vector is going to look like, which you're going to see in a second. Okay, so our imaginary axis, our real axis, again, it can be drawn as either a single point, 4 plus 5i, and how I got that is I went over 4 on the real axis and up 5 on the imaginary, okay? Or we can draw it as a vector. This is the way we will be doing it. Okay, this is a vector. Imaginary axis is I. So you go over 8 on the real, and then up 3i on the imaginary. I is always y, yeah. Okay. So again, it can be represented as a point or as a vector. Which one are we going to use for our purposes? Vector, okay? Notice this arrow does not extend past the point. If you extend it past, it's wrong. Understood? Okay. Okay, so on the next page, we're going to go through some adding and subtracting of complex numbers. What we're going to do is we're going to grab and drag to see how they change. Okay, so I have a plus bi plus c plus di. C and d are just different variables to represent different values. Right now, I have the vectors 2 plus 4i, which is this value here, this vector here, okay? I also have 3 plus a negative 2i, so over 3 down 2, it's right here. You're able to see how we got those? Okay. Now, their sum is 5 plus 2i. How did I get that? Just add their like terms, right? 2 plus 3 is 5, 4i minus 2i is 2i. Okay, this vector here is what we call the resultant vector, and that's very important. We're going to talk about that in depth, okay? So their sum or difference is what we call the resultant vector, okay? Notice what it creates. What is that? It's a parallelogram. Awesome, okay? So every single time you have a sum or a difference of two complex numbers, it's going to create, when you graph it, a parallelogram. If it doesn't create a parallelogram, you did it wrong, okay? So make sure that every single time you do these, you wind up with some sort of parallelogram. Okay, so what you're going to do is you're going to grab, you're going to grab these vectors and you're going to change them to see how it changes. So if you want to make it going the other way, do it. Okay, so I want you to play around with that for a minute. All you have to do is grab a point and move it around the vector. Yeah, the point on the vector. So grab that and move it around, and I want you to notice how these change. Okay, so play for a minute. Okay, so did anybody get it to do anything interesting? What did you get it to do? 6 plus 1i. Okay, anything that would make it disappear, perhaps? Why did it do that? What's 0? Your imaginary part. So we can get vectors right on an axis, right? I can do that the same way going this way if my real portion is 0, okay? So you can play around these. You can make it a nice rectangle depending. All right, so there's a lot of different things you can do. You can even make it so that both portions are 0, okay? Now the magnitude wouldn't be 0, but the complex number itself is 0, okay? We done playing? Okay. Okay. You can't move the resultant. Okay, hold on. Okay. The sum of any two vector quantities is equal to the resultant of the parallelogram that is constructed using the two vectors as two consecutive sides of a parallelogram. On the following page, you will see this visually. No, we don't, because I got rid of it. Here it is. It's on the next page. Okay? So, vector 1, vector 2, their resultant is right through the center. Got it? Now that's for the sum of two vectors. We're going to wind up seeing that when we find the difference, that resultant isn't necessarily in the center. Okay, so you're going to see some different things. It's still going to create a parallelogram, but it's not going to be, I don't know. I had an extra page in there. No, just leave it. Okay, so subtracting is a little bit different because we know we need to do what? Yes. Say it again. Yeah, keep change. A fancy way of saying you distribute through that negative, right? Okay, so you have to keep that in mind when you're subtracting. So what I want to look at is 2 minus 3i minus 5 plus 2i. Okay? So again, I have to do what? Yeah, I got to distribute through that negative. 2 minus 3i minus 5 minus 2i, right? We have our original two vectors, 2 minus 3i here. And we have the other vector of 5 plus 2i. Do I have 5 plus 2i? Why don't I have 5 plus 2i? Because what did I have to do? Yeah. So my other vector here is negative 5 minus 2i. Okay? So we're adding those. So essentially, all subtraction is addition. Okay? So your resultant falls in the center. But in order to get that result, you had to do what? I'm going to remind you again. Keep change, distribute through that negative, okay? So before you graph with subtraction, you have to change those values and then graph that vector accordingly, okay? Did you hear me? You're looking at me confused, Joe. Before you graph, change the values and then graph, okay? All right, so it doesn't make any sense to keep looking at more of these. I want you to actually try some of these. So you have your notebooks out, please. If you don't, please take them out. You're going to need to do this on paper. Okay. This is what I need. Where are you? Okay, so I want you to start by graphing the complex number 2 plus 3i. Please make sure that you label your axes appropriately. You're going to do it on paper, okay? You can't do this in your calculator. So you're going to sketch a little xy axes. You're going to label, not xy, you're going to label your axes, and then you're going to graph that complex number. I would like you to graph it as a vector, not as a point. Okay, so I'll give you a second to do that, and we'll come right back. Okay, so 2 plus 3i. How do I graph it, guys? Not everybody at rough. Over 2 and up 3. Good. And what am I going to do with that point? Arrow, yep, back to the origin, arrow on the point, and I label it 2 plus 3i. Any problems with that? Pretty easy? I am labeling the vector, not the point. I can label the point if I want. I prefer to label the vector. You're right. Take that as a no. Okay, so I want you to add graphically negative 2 plus 4i and 4 plus I. So in order to add it graphically, you have to graph each original vector and then graph their resultant vector. Okay? Actually, let's use this one again. I'm sorry? Yes. No. New graph. Please and thank you. I'm shush. Okay, so in order to graph the sum, you have 4 plus I. 1, 2, 3, 4 plus I. So this is your original, right? And negative 2 plus 4i, negative 2, 1, 2, 3, 4. And then your sum, shush, which is 2 plus 5i. When we combine like terms, 1, 2, 1, 2, 3, 4, 5. And there's your resultant. Now, you should connect those with a dotted line to make sure that you do indeed at the end have a parallelogram. All right, I want to do one more. Do we have time? The bell doesn't ring till 33. Your homework is up on the board, 28 through 31. Do you have to do every single one of them? No, absolutely not. Just do a couple of each. Okay, we have one more. Time for one more. I want you guys to do the subtraction. Now, remember, are you guys listening? When you do subtraction, before you graph the resultant, you have to do what? Yeah, so this says subtract from. What does from mean when you're dealing with subtraction? Yeah, this is your first one, minus. Okay, so your vectors are going to be 3 plus 2i plus what? 1 minus I. So here's the two vectors that you're going to graph. Okay, and then the resultant, which is 4 plus I. So these are your three vectors that you'll graph. Okay, so when you're doing subtraction, you have to distribute through that negative first, determine what your new vector is, okay? Then find the sum of the two new vectors and graph all three, okay? So we had 3 plus 2i. We had 1 minus I, so over 1 down 1. And we had 4 plus I. This is your resultant. So here's your parallelogram. Did we still get a parallelogram? Yes. Okay. All right, so again, homework is pages 28 through 31. Please do not do every single one of them. You do not have to do number 2 on page 28. It asks for the modulus. You don't need that. Okay, so number 2 on page 28 you don't need to do. Tomorrow we're going to review for the test, which is going to be Thursday and most likely Friday as well, because you guys tend to work a little slower than you guys like to be thorough. That's a very nice way to put it. Okay, so any questions? We're good? We're good.